Hello everyone, thank you very much for watching my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, you want a cookie for class? Very good. And welcome to SAT, ACT Prep. We're going to go through some more miscellaneous practice sets. So we're going to present these advanced problems in pairs, sets of two, and we're going to get 3 examples of each of them to make sure that you get ample exposure to these advanced SAT, ACT questions. These are going to be cross-sectional, so often a lot of the problems are going to involve multiple subtopics in one word problem. So let me share my screen with you. If you have any questions at any point, you can drop a comment below or in the live chat feed. If you find these videos helpful, then I invite you to subscribe and hit the like button. And welcome to all my new subscribers. Thank you very much. There's also a slight delay with the iPad, but I'll try and mitigate that as much as possible. I'm going to give you 6 minutes to look at 1 and 2. 2 minutes in, I'll start to solve. So they both are in reference to this diagram containing rectangle ABCD. Notice there are some facts in the right-hand square there that you need to apply to the diagram. Question number 1 is asking what is the perimeter of triangle ADE in the diagram above, and question number 2 is asking what is the area of triangle ADE in the triangle above. So I'll give you 6 minutes. I'll keep track of the time in the upper left-hand corner, and I'll update it per minute. About 2 minutes in, I'll start to solve if you have any, if you need any hints. Okay, so for number one, well, for both of them, we really need to just solve this complete shape, meaning going from the given information, which notice we only have one side length that's given to us, that's side length AB. So we really need to start from that given side length, apply the geometric principles and concepts that we're allowed to identify in the problem, being the other given information that angle AEB is 30 and EDC is 45, and most importantly that the overall shape ABCD is a rectangle. So the geometric definition of a rectangle, it has to have all angles are 90-degree angles and sides are equal, congruent, and parallel. So AB has to be equal to side length DC if this overall shape is a rectangle. So we know if AB is 4, the other side length DC is 4. Now they also tell me in the given information that angle measure AEB is 30 degrees. If AEB is 30 degrees and ABE, the right triangle, right angle, is a 90-degree angle, then I can solve immediately for what the missing angle is, because the sum of the interior angles of any triangle, whether it's a right triangle, an obtuse triangle, an acute triangle, an equilateral triangle, whatever type of triangle, has to have an interior sum of 180 degrees. So if you know two angles, you can always solve for the third by just subtracting those two from 180. So 180 minus 90 minus 30 will give you 60. So this is a 30, 60, 90 right triangle, and we've talked about these before. This is the most special, highest category of triangles that we cover on the SAT, and they're special, or they're mathematically relevant because of what you can do with them, because it only requires one given side length in order to solve for all others. Notice that the Pythagorean Theorem, we can only use it for a right triangle, which isn't any further of a limitation because a 30, 60, 90 has to be a right triangle as well. However, the Pythagorean Theorem has three variables, right? It's a squared plus b squared is equal to c squared. So you have to have at least two side lengths in order to solve for the third. If you know that it's a 30, 60, 90, you only need one side length, and that's where they can really test whether you know these side length ratios, angle to side length ratios, because you wouldn't be able to solve here with the Pythagorean Theorem. So the first thing that you do, these ratios, they will be given to you in the formula sheet on the SAT. They won't be on the ACT. However, by the time we finish preparing for the SAT, you're probably going to have them memorized, and it's a good idea to try and memorize them. So a 30, 60 to 90, whenever a triangle has angles in a ratio of 30 to 60 to 90, it must have side lengths in a ratio of 1 to root 3 to 2. That doesn't mean that the side lengths have to be 1, root 3, and 2. They have to be direct multiples. There has to be one number that you can apply to each one of those ratio elements in order to get the actual side lengths of the triangle. So you start by just writing down, once you identify that it's a 30, 60, 90, you start with the given ratio. So I wrote in red there, 30 to 60 to 90 is to 1 to root 3 to 2. Leave a little bit of space and draw a line. And then you're going to associate the given information based upon what angle it is opposite of. The given side length of AB here in this diagram is opposite the angle of 30 degrees, or that has a 30-degree angle measure. So underneath the ratio element that corresponds to the 30-degree angle, which is 1, I'm going to write 4. So in order to go from 1 to 4, you need to figure out what is the common multiple. What number times 1 is 4? That's 4, right? Because 1 times 4 is 4. So that means that's the common multiple that you need to apply, to the other two ratio elements in order to solve for the actual side lengths, other two missing side lengths. So this is telling us root 3 times 4 is 4 root 3. 2 times 4 is 8. So the side length, the missing side length that's opposite the 60-degree angle is going to have a length of 4 root 3 units. The side length that's opposite the 90-degree angle, or the hypotenuse of this triangle, is going to have a length of 8 units. So I filled in like navy blue, 4 root 3 and 8 in that triangle. Then I'm moving over to the other triangle, because notice These two triangles are special right triangles. One is a 30-60-90, the other is a 45-45-90. But the triangle in question that they're actually asking me about is not a special right triangle. It's not even a right triangle as far as we know. So we have to kind of work around everything else in order to identify the side lengths in which the two shapes share. So the first triangle, ABE, shares that hypotenuse with the triangle in question, AED. And then the second triangle on the right also shares its hypotenuse with that triangle. So now let's move over to the second triangle on the right. We know that one angle has to be 90 because it's part of a rectangle. And the other they give us is 45. So we know that the missing side length is going to be equal to 180 minus 90 minus 45, which is 45. So this is a 45, 90 degree triangle. So we can, again, write the ratio. It's just a different ratio. So there's two that you have to memorize. 45, whenever a triangle has angles in a ratio of 45 to 90, it must have side lengths in a ratio of 1 to 1 to root 2. The given information, or the given side length, or the association that we can make from the given side length of AB, because this is overall a rectangle, means that side length DC also has to be congruent to side length AB, so it also has to have a length of 4 units. DC is opposite the 45 or a 45 degree angle measure. So it doesn't matter which one you choose because they're both 45. So I put 4 underneath the ratio element, one of the ratio elements representing the 45 degree angle. And in order to go from 1 to 4, ask yourself what do you have to multiply by. So again, it's 4. So multiply the other ratio elements by that common multiple. 1 times 4 is 4. Root 2 times 4 is 4 root 2. So the side length that's opposite the other 45 degree angle measure is going to have a length of 4 units. The hypotenuse, which is opposite the 90 degree angle measure, is going to have a length of 4 root 2 units. So now we have all the information. Oh, and one last thing, remember that this is overall a rectangle. So side length AD up on the top of the rectangle has to be congruent to side length BC, which is the base of the rectangle. Notice that the base of the rectangle is made up of 2 separate segments. We have 4 root 3 and we have 4. So I can combine those together to understand that the length of the entire thing has to be 4 root 3 plus 4. So that's where I'm getting that information for the side length AD. So the perimeter is just the sum of all the sides. So we're going to take, starting with side length of 8 for side length AE, I have 8 plus 4 root 3 plus 4 root 2. And I'm just matching them up in the order that they present them in the answer selections and combining the like terms of the constants. 8 plus 4 is going to give me 12. I don't have common radicants with the radical values, so I can't combine them together. One has a radicant of 3, the other has a radicant of 2, so we can't combine them as they're written. They're just already in simplified form. So the answer there for number 1 is going to be 12 plus 4 root 2 plus 4 root 3. And that's answer selection D. Answer selection B, as in boy. Number 2, they want the area. So now we figured out, we solved for all the components of this diagram. So now we just need to apply the area formula for a triangle, which is 1/2 base times height. Remember that the height has a specific definition. It's from the apex to the base at a perpendicular, with the altitude at a right angle. So that altitude has to be perpendicular to the base of the triangle. And when we get into triangles specifically, I'll show you how that can get a little bit messy, because the height is not always a side length. That only happens with right triangles. However, this is what I'm talking about. The height would be this red line that I'm drawing in. It's from the apex, which is the highest point in the triangle. Here this triangle is kind of flipped upside down, but just imagine it's flipped around directly straight down to the base. Notice that that's the same thing because this overall shape is a rectangle. That's the same thing as just these side lengths AB and DC. So notice that the height of this triangle is 4, and we can tell that by associating equivalent characteristics between that triangle and the overall rectangle. It's the same as the side length or the width of the rectangle. So the height is 4, the base is 4 root 3 plus 4. I applied the 1/2 to the coefficient of 4, so I didn't have to split it between the 4 root 3 and the 4. So I reduced the 4 by 1/2, so then it became 4 root 3 plus 4 quantity times 2. And you just need to make sure that you apply that 2 to both the coefficient of 4 in 4 root 3 and the constant value of 4. So 4 root 3 times 2 is 8 root 3. 4 times 2 is 8. So our final answer for number 2 is going to be 8 root 3 plus 8. Let's look at 3 and 4. I'm going to give you 6 minutes. They want to know what the perimeter of triangle ADE and the area of triangle ADE is in the diagram above, and they've changed the given information of side length AB to now be 6 units instead of 4 units. So I'll give you 6 minutes. After 2, I'll start to solve. Okay, so for number 3, we need to just start with the 6 on the outside and work our way through with the special right ratios, special right triangle ratios, solving for the sides of triangle ABE and triangle DCE, because they share 2 sides in common with the triangle that we're asked about. So the first triangle, triangle ABE, is a 30, 60, 90, so we can set up that ratio. If the angles of a triangle are in a ratio of 30 to 60 to 90, then their side lengths must be in a ratio of 1 to root 3 to 2. So start by writing that ratio, 30, 60, 90, 1 root 3, 2. Draw a line, leave a little bit of space, draw a line, and then match up the associated given value. Here, the given value of side length AB is opposite the 30-degree angle measure. So I'm going to put 6, which is the given unit length of the given side length AB, opposite the 30-degree angle measure, underneath the ratio element that corresponds to the 30-degree angle, which is 1. Now, in order to go from the ratio element of 1 to the actual side length of 6, what must I multiply by? Well, 1 times 6 is 6, so 6 is the common multiple that I need to apply to the other ratio elements of root 3 and 2. 6 times root 3 is 6 root 3. 6 times 2 is 12. So the side length that's opposite the 60-degree angle measure is going to be 6 root 3 units long. The hypotenuse of triangle ABE, opposite the 90-degree angle measure, is going to be 12 units long. Moving over to the second triangle, which we know is a 45, 45, 90-degree triangle, that has to have side lengths in a ratio of 1 to root 2. So start with that given ratio set. That's never going to change. It's just either a 30, 60, 90, 1 root 3, 2, or a 45, 45, 90, 1, 1 root 2. Excuse me, 1 root 3, 2, or 1, 1 root 2. So here the given value is opposite a 45-degree angle measure. So underneath the ratio element of 1, I'm going to write the given side length of 6. It's not given. We're able to conclude that side length DC is congruent to side length AB because the overall shape is a rectangle, and we know that rectangles have congruent and parallel opposite sides. So if we have a given side length of 6 and we have a ratio element of 1, to go from 1 to 6, we need to multiply by 6. 1 times 6 is 6. So then multiplying the other ratio elements by that common multiple of 6, we're going to get 1 times 6 is also 6. We're going to get another side length of 6. And root 2 times 6 is 6 root 2. So the hypotenuse is 6 root 2. And the other side length opposite the second 45-degree angle is also going to be 6 units long. Adding up the relevant side lengths of the missing triangle, or triangle ADE, we're going to have 12 plus 6 root 3 plus 6 plus 6 root 2. The constant values of 12 and 6 can combine to make 18, leaving us with a final answer of 18 plus 6 root 2 plus 6 root 3. Notice that there's no common radicand in those radical values, so we can't combine them. 6 root 2 plus 6 root 3 is in final simplified form. For number 4, we need to calculate the area. So the formula for the area of a triangle is 1/2 base times height. The base here is just going to be the sum of the component parts of its opposite side in this rectangle. We know that rectangles have to have congruent and parallel opposite sides. So if I know that side length BC is made up of a sum of segments BE and EC, namely 6 root 3 and 6, I can just put them together and say that the whole thing must be equal to 6 root 3 plus 6. So if BC is 6 root 3 plus 6, AD is congruent to BC, so its length also has to be 6 root 3 plus 6. So the base is 6 root 3 plus 6. The height is the same thing as the width of the overall rectangle, which is 6. So we have 1/2 times 6 root 3 plus 6, quantity times 6. I'm applying the 1/2 to the coefficient all the way at the end, so I don't have to distribute it within the parentheses. Remember that whenever you have a complex form that's separated, when you have more than one monomial separated by addition or subtraction within parentheses, you always have to distribute it to all terms inside the parentheses. So I'm just trying to simplify the math here a little bit by taking that 1/2 to the 6 rather than to both quantities inside the parentheses. So that's going to leave me with 6 root 3 plus 6 quantity times 3. I just need to make sure that I distribute that 3 to both the 6 root 3 and to the 6. So 6 root 3 times 3 is going to be the same thing as 6 times 3 times the square root of 3, or 18 root 3. There's no radical in the 3, so that radicand, the number underneath the radical sign, is unaffected by multiplying it by 3. 6 root 3 times 3 is 18 root 3. 6 times 3 is 18, so our final answer is going to be 18 root 3 plus 18. Let's take a look at the last two questions dealing with these concepts, 5 and 6. So here they've made it a little bit more challenging. The given side length now is a radical value. So everything else is the same, but side length AB, now has a side length of 4 root 3. Number 5 is asking what is the perimeter of triangle ADE, and number 6 is asking what is the area of triangle ADE in the diagram above. So again, I'll give you 6 minutes and I'll start to solve after 2. Okay, so for number 6, if we have that side length AB is 4 root 3, going around and applying the 30, 60, 90 ratios of 1 to root 3 to 2, now we're going from a whole number, an integer value of 1, to a radical value of 4 root 3. So to go from 1 to 4 root 3, we have to multiply by 4 root 3. So I'm going to multiply everything by 4 root 3. You just have to remember your rules with operations involving radicals. Remember that they're completely parallel to the operations with fractions. In order to add or subtract, you need common radicands, the number underneath the radical sign. Once you have common radicands, you keep the radicand, add or subtract the coefficients, the numbers outside the radical signs. With multiplication, it's just straight across, coefficient times coefficient, radicand times radicand. Number outside times number outside, number inside times number inside, while keeping the radical sign intact. So if we have root 3 times 4 root 3, that's the same thing as 4 times root 3 squared, because it's root 3 times root 3. Those are opposite operations, square root and squaring, so they just eliminate and become 3. So the side length opposite the 60-degree angle measure is going to be 4 times 3, or 12 units long. So line segment BE is 12. And then 2 times 4 root 3 is going to be 8 root 3. So the hypotenuse is 8 root 3 units long. Going to the 45, 45, 90-degree triangle, because it's a rectangle overall, we know that side length DC is also 4 root 3. So I'm going to use the 45, 45, 90 is to 1 to 1 to root 2 ratio, and applying the 4 root 3 to go from 1, which is the ratio element corresponding to the 45-degree angle. So to go from 1 to 4 root 3, again, we have to multiply by 4 root 3. 1 times 4 root 3 is 4 root 3. Root 2 times 4 root 3 is going to be 4 times the square root of 2 times 3. Notice that root 2 doesn't have a coefficient. Technically it has a coefficient of 1, but that 1 times anything doesn't do anything. It's that same something that you started with, so it's unaffected. But notice that the root 2 doesn't have a coefficient to affect the 4, so the 4 just carries through as the coefficient. The radicand, however, is 2 times 3, which is going to be 6. So the perimeter is going to be 8 root 3 plus 12 plus 4 root 3 plus 4 root 6. Combining the root 3's, 8 root 3 plus 4 root 3 is going to be the same thing as 8 plus 4 times the square root of 3, or in other words, 12 root 3. So the final answer here is going to be B, 12 plus 4 root 6 plus 12 root 3. And number 6 is asking for the area of that triangle. So the base is the sum of the component parts on the opposite side of the rectangle. So we're going to have 12 plus 4 root 3 as the base, 4 root 3 is the height, and the equation for the area is 1/2 base times height. So applying that 1/2 to the 4 root 3, that's just going to become 2 root 3. And then I'm going to distribute the 2 root 3 to the 12 and to the 4 root 3. Making sure to apply coefficient times coefficient, radicand times radicand. And if one of the values doesn't contain one of those components, then that component on the other value is unaffected. So 12, for example, doesn't have a radical, so it's just 12 times 2, and the radical of root 3 carries along. So 12 times 2 root 3 is going to turn into 24 root 3. 4 root 3 times 2 root 3, we take it bit by bit. So 4 times 2 is 8, so the outside number is going to be 8. Underneath the radical, we're going to have 3 times 3. However, 3 times 3 is 9, which we can evaluate using the square root, because the square root of 9 is 3. So then that'll just simplify into 8 times 3, which is 24. So our final answer here is going to be 24 root 3 plus 24. Okay, some different problems here, 7 and 8. Question 7 asks, if g of x is equal to 3x squared minus 2x plus 4, and h of x is equal to 3x squared minus 3x minus 14, what is the value of h of g of 2? Question number 8 asks, in a jar filled with many different types of coins, 40% of the coins are gold and 60% of the non-gold coins are silver. What percent of the coins are neither gold nor silver? And omit the answer, the percentage sign, when entering your answer as a gridden. So both of these are griddens. I'm going to give you 6 minutes, and after 2, I'll start to solve. Okay, so for number 7, these are composite functions. So we're evaluating one function for a given value, and then whatever that output is, we're using as a new input value for the second function. So you have to work from the inside out. Inside the parentheses, we're really evaluating g of 2 all the way inside of these parentheses sets. So g of 2 is just taking the function of g, which is 3x squared minus 2x plus 4, and inputting a value of 2 for x. So we're going to get 3 times 2 squared minus 2 times 2 plus 4. So that's going to turn into 3 times 4 minus 4 plus 4. The minus 4 and the plus 4 cancel, leaving us with just 3 times 4, which is 12. So g of 2 is 12. So 12 is now going to be the new input value that we use for the function h of x. So for h of x, wherever I see an x, I'm going to substitute in 12. So that's going to give me 3 times 12 squared minus 3 times 12 minus 14. 12 squared is 144. 3 times 144 is going to be 432. 432 minus 36 minus 14 will give you 382. So your answer to number 7 is 382. For number 8, this is a really typical advanced percentage problem, and they use these types of missing parts of the whole, especially when you're talking about bifurcated problems or problems that have bifurcated context. And bifurcated means split into 2 parts. So you're either this or that. And these types of situations are really useful to be represented using a tree diagram, because you can say this whole level of the tree diagram has to add up to 100% of that criteria, but I can split it between the two. It is or it is not. And so you only need to know one portion of that, because the whole value is 100% of that subtotal at any one point in that tree diagram. So for example, here they say in a jar filled with many types of coins, 40% of the coins are gold. So if I start the tree diagram with the overall jar, and I have one branch that includes all gold coins, and that they tell me is 40% of them are gold, that means 60% or 100% minus the 40% that are gold have to be non-gold. Then I can split up the non-gold category, because they say that 60% of the non-gold coins are silver. So 60% are silver, 40% are non-silver. So 40% of the 60% of the whole jar are both non-silver and non-gold. So you're going to have to multiply there. When you're talking about probability or statistics, it's useful to keep in mind from an English standpoint what conjunction is being used. So if they use the word and between multiple criteria, that's usually going to imply multiplication of the two probabilities together, because it's considered two different criteria that has to be satisfied by every individual that satisfies the overall condition. But the word or is indicative of addition or adding the two probabilities together, because you can either be this one or that one, so that expands the possibilities because it's a less restrictive criteria. So I hope that that makes sense. If there's any questions on that, then let me know. But if you have to be this and that, you're applying two criteria to the same individual. But if you could be this or that, that means any one individual has two criteria that will satisfy the overall condition. So that's less restrictive. Here, they have to be both. They have to be non-silver and non-gold. So that's a more restrictive criteria, and that's indicative of multiplication of the probabilities. So we're going to take 40% times 60%, which is going to give us a decimal answer of 0.24. We need to make sure that we convert that decimal into a percentage. If they ask you for a percent and you enter in the decimal form, it's going to be wrong. If you entered in 0.24 for this question, the computer would grade it as incorrect. because they ask specifically what percent of coins. And so they expect you to know that that means you need to convert by moving the decimal place 2 places to the right, adding zeros if necessary, in order to convert that into 24%. And we're going to omit the percent sign, so we're just going to enter the integer answer of 24 for question 8. If you have any questions, then please let me know. Otherwise, let's look at 9 and 10. 9 asks if j of x is equal to 3x squared minus 12x minus 20, and k of x is equal to 2x squared minus 8x minus 8, what is the value of k of j of 6? Question number 10 asks, in a closet filled with many different types of toys, 54% of the toys are red, and 40% of the non-red toys are fire trucks. What percent of the toys are neither red nor fire trucks? That's interesting. I guess they're not red fire trucks. It's a different color fire truck. But I'll give you 6 minutes. Please attempt those 2 problems, and after 2 minutes, I'll start to solve. Okay, so for number 9, first we're going to evaluate j of 6. So using an input value for the function j of x, we're going to have 3 times 6 squared minus 12 times 6 minus 20. 6 squared is 36. 3 times 36 is 108. 12 times 6 is 72, so we're going to have 108 minus 72 minus 20. That's going to give you 16. So 16 is the new input value that we're going to use in the function of k of x. So substituting 16 for x in k of x, we're going to get 2 times 16 squared minus 8 times 16 minus 8. 16 squared is 256. 8 times 16 is 128. 2 times 256 is 512. So we're going to get 512 minus 128 minus 8, which will give us a final answer of 376. For number 10, we can start with the overall closet and separate it into red and non-red toys. They say that 54% of the toys are red, so that means that 100% minus 54%, or in other words, 46% of the toys have to be non-red. They say of the non-red toys, 40% are fire trucks. So we can take the non-red cluster or category and split it into fire trucks versus non-fire trucks. If 40% of the non-red toys are fire trucks, then 60% of the non-red toys are non-fire trucks. So to be non-red and non-fire trucks, or in other words, to be not red and to not be a fire truck, that would be 60% of the 46% of the original closet. So it's 60% of the non-red, and the non-red is 46% of the whole closet. So because we're layering those two criteria on top of each other, it's both criteria together, we need to multiply those probabilities. So we're going to have 60% times 46%, which is going to give us 0.276, which is 27.6%. If you have any questions, then please let me know. Otherwise, these two questions will bring us up to the end of class today. Number 11 asks if L of x is equal to 4x squared minus 18x minus 6, and k of x is equal to 2x squared plus 2x minus 24. What is the value of k of L of 5? And number 12 asks, in a bin filled with many different types of stuffed animals, 80% of the stuffed animals are made of cotton, and 16% of the non-cotton stuffed animals are lions. What percent of the stuffed animals are neither lions nor made of cotton? I'll give you 6 minutes, and after 2 minutes, I'll start to solve. Okay, so for number 11, if we're evaluating from the inside L of 5, so an input, we're using 5 as an input value in the function L of x, so we're going to get 4 times 5 quantity squared minus 18 times 5 minus 6. 5 squared is 25, 4 times 25 is 100. 18 times 5 is going to be 90, so we're going to end up with 100 minus 90 minus 4. That'll give us, 100 minus 90 minus 6, rather, that will give us 4. And so 4 is going to be the new input value for the function of k. So then we're going to have 2 times 4 squared plus 2 times 4 minus 24. So that's going to be 2 times 16 plus 8 minus 24. So that's going to be 32 plus 8 minus 24, which will end up giving us 16. So the answer to number 11 was 16. For 12, if we separate this bin into cotton and non-cotton, they say that 80% of the stuffed animals are made of cotton, so that means 20% of the stuffed animals are not made of cotton or made of something that is non-cotton. And then they say 16% of the non-cotton stuffed animals are lions, so that means that 84% are non-lions. If we're going to have both of these criteria together, then we're going to have to multiply them together. So we're going to have 84% times the 20% of the whole bin. And so that's going to give us a final answer of 16.8%. Making sure that you enter your answer as 16.8, not 0.168. If you have any questions on anything that we've done today, then please let me know. Otherwise, I hope you have a wonderful day, and I will see you all tomorrow. However, Dr. Tot, do you want to say goodbye to everybody and get a cookie? Come on, let's say bye. No, you can't. You have to say bye first. Come on. Just trying to cheat. Can you say bye? You sit. Come on. You guys sit. Sit. Come on. You say bye. You say bye. Why don't you want to say bye anymore? Can you look in the camera and say bye? Say not really. No. Well, thank you very much for watching. Hope you have a wonderful day, and I'll see you all soon.